The automobile of the late 20th century has been a product of evolutionary change. Throughout the last decade, the need for weight and space savings has in part been met by the almost universal conversion of conventional parallelogram steering systems to the rack and pinion system. Almost all vehicles produced and sold today will incorporate rack and pinion steering. Rack and pinion is going to be with us for a long time, and the amount of aftermarket business you will see in this area is going to increase dramatically. That trend is expected to continue in the foreseeable future. TRW introduced their first rack and pinion system in England. Its success in the 1947 MG soon made it a standard on most manually steered European cars. In the early 70s, TRW's rack and pinion was the first system to be adapted by a major North American automobile manufacturer for their power steering equipped models. TRW's historical involvement in rack and pinion systems has provided the experience and expertise needed to allow them to become the largest independent producer of rack and pinion gears in the world. In our Rogersville, Tennessee plant, one of TRW's steering and suspension manufacturing facilities, power rack and pinion units are produced for original equipment manufacturers. Highly automated manufacturing, precision work performed by skilled operators, and extensive testing assures consistent, high-quality rack and pinion production. Using the company's tremendous experience and resources as a basic OE manufacturer, the next logical step was to begin to supply remanufactured rack and pinion gears to the replacement market. To meet the quality and cost needs of the consumer, TRW has facilities dedicated for the sole purpose of providing a quality remanufactured rack and pinion gear, as well as a plant which is devoted to engineering and research and development. A quick tour of this plant will demonstrate the steps in remanufacturing a rack and pinion gear. All TRW replacement rack and pinion gears are completely remanufactured, not just rebuilt. Each used gear is completely disassembled, with each component inspected and placed in bulk storage. Each component must meet specific criteria to be considered for reuse. Parts that pass first inspection are thoroughly cleaned in a high-pressure chemical washing operation. Housings are then passed through an abrasive cleaner to prepare rack housings for reassembly. Racks are magnafluxed to test for cracks or flaws and are tested for absolute straightness. Racks are then polished to remove all rust or surface flaws and to ensure a smooth seal contact surface. Aluminum pinion housings are bored and sleeved with a steel liner to ensure extended wear. All rack and pinion components are then assembled to form a quality remanufactured steering unit. Before the final test, all gears must pass a leak test. Gears are submerged in an isopar solution and charged with low pressure, then with high pressure. Once gears pass both checks, they are now ready for final testing on test stands designed and built by TRW engineers. Each gear must go through a series of 6 tests. Here, the operator is checking for the proper meshing of the rack and pinion gears to ensure that these components are compatible. Another test, performed with fluid under pressure, measures torque at the input shaft to determine that proper steering assist is present. This test will also check that a proper balance exists between right and left turns. The pressure is then increased to check for leakage around the seals. TRW performs the most extensive computer testing in the aftermarket on every gear it remanufactures. Acceptable gears are assigned a serial number and the test data stored in order to draw comparisons in the event that the gear is returned for warranty. Any gear that fails to meet any one of the test requirements is sent back for disassembly. Final assembly includes the installation of inner socket assemblies, bellows, tags, labels, instruction sheets, and finally, packaging. The product is now ready for shipment. We've had a brief tour of the TRW remanufacturing process, showing the stringent quality standards each component must meet and the rigid test procedures each gear must undergo to ensure that every one that finds its way into your hands will perform at peak efficiency. As a result, TRW offers a lifetime warranty on every long rack we sell allowing you to install them with confidence. Once the customer has left her car in your hands for repair, the first step to take in any rack and pinion inspection is to do a thorough road test. This will help you determine if problems exist other than the symptoms that are apparent to the customer. The road test will give you a better idea of just what problems the customer is experiencing. Having determined a steering problem exists, the job of accurately troubleshooting the rack and pinion steering system begins. The first step is to visually inspect hoses, belts, and fittings for deterioration, damage, and leakage. Missing or loose hose clamps and loose or worn belts are often the cause of steering-related problems. Check the level and condition of the power steering fluid. Low levels can cause foaming and aeration, which may lead to noisy operation and poor assist. If you suspect power steering pump problems, this may be the time to test the pump with a pressure and flow gauge. If the pump is faulty, replace it. Discoloration of the power steering fluid usually indicates contamination. This condition is caused by pump or rack and pinion housing wear and will eventually lead to fluid leakage. Your customer may have a car that suffers from steering stiffness under cold starting conditions and persists until the power steering fluid has warmed up. This condition, commonly referred to as morning sickness, is difficult for the technician to diagnose unless he can test the car while it is still cold. A common symptom is a darkened power steering fluid. Morning sickness is caused by grooves being worn in the aluminum pinion housing by the hard glass-filled seals around the control valve. A less common problem is often referred to as center wear condition. The symptom is a slight wander at high speeds while steering straight ahead. Center wear condition is a result of internal fluid leakage caused by excessive wear in the rack piston housing. Morning sickness and center wear condition can only be corrected by replacing the gear. The next step is to perform a procedure developed by TRW known as the dry park check. This procedure is a reliable way to inspect all types of steering systems. Be sure the engine is shut off, but keep the ignition unlocked so the steering wheel can move freely. Meanwhile, check the steering wheel and the column for signs of disrepair. It is essential in the dry park check to have the car in a natural position with the weight of the vehicle fully supported by the wheels. This is best achieved on a drive-on lift, an alignment rack, or even on the floor if you have room to maneuver under the vehicle. Use the TRW under-car inspection pad as a checklist and as an estimate sheet. Position yourself under the car and grab hold of the input shaft where it enters into the pinion assembly. Rock the input shaft or steering wheel back and forth to start the system in motion. If access to the input shaft is difficult, have an assistant operate the steering wheel. Now you can inspect the various parts. This connector on the input shaft is a cardan universal joint. If the protective boot covering the U-joint coupler is damaged, or if there is no boot, as is the case here, road contaminants can impair its performance. On early model Chrysler cars, particular attention should be paid to the steering coupler. In many cases, binding or hard steering and noise while turning may be misdiagnosed as a faulty rack. The problem is often the steering coupler. To verify, spray it thoroughly with a rust penetrant fluid and cycle the wheel back and forth. If the tightness or noise is eliminated, the problem has been identified and replacement of the coupler is necessary. Another type of connector, this one on the Ford vehicle, is the rubber and fabric or rag joint. The rubber sandwich should be intact and in good condition. Replace the joint if it's in poor condition or contaminated with oil. Checking for rack and pinion seal leakage should be part of any inspection. Worn or damaged internal seals, common symptoms of rack and pinion failure, can be detected by doing a visual inspection. Start by checking the top of the pinion housing. Fluid leakage here may indicate a worn upper pinion shaft seal. Then inspect the bellows for fluid leaks by removing the small clamp and checking inside. Any sign of power steering fluid here indicates internal seal failure. If you detect leakage in either of these areas, recommend replacement of the rack and pinion unit. Next to check are the outer tie rod ends. While rotating the steering coupler back and forth, look at the tie rod end as well as the steering arm it is attached to. Any movement between the tie rod end and the steering arm indicates that replacement of a part may be necessary. Check your OEM manual for specifications and procedures when in doubt. Grab the tie rod end and twist it to feel for any roughness or binding. Lack of proper lubrication can cause these problems, and replacement of parts is recommended. The inner socket assemblies are a little more difficult to check. They are located inside a bellows that protects the rack seals and the inner socket assembly from contaminants. Bellows made of rubber or soft synthetic plastic can be pinched where the socket and stud come together. Rotate the input shaft. If any looseness or play is detected, replace the inner socket assembly. If the vehicle uses the hard plastic type bellows, then the pinch method cannot be used. The simplest check is to look and feel for movement at the point where the inner socket assembly enters the bellows. If looseness is detected, replace the inner socket assembly. Another method of checking is to remove the clamp from the boot and do a visual inspection. Be sure to examine the boot itself for any deterioration, holes, or tears. Any problems with the boot can lead to inner socket assembly failures, or worse, ruin the seals in the rack housing. This example shows a rust buildup caused by moisture entering through the torn bellows. The rust acts as an abrasive on the internal seals, resulting in fluid leakage. This condition is also commonly found on recently replaced racks if the small bellows clamp was not installed properly. Good preventive maintenance of replacing the boots and making sure the clamps are tight can avoid costly repairs such as inner socket or complete rack and pinion replacement. Now, inspect the mounting bushings. If they are in poor condition, the entire rack assembly will move in the mounts. On the road, that will translate to sloppy steering and road wander. Mounts are subject to extreme temperatures, oil absorption, stress, and road debris. So check them out well. Replace if questionable. Using the recommended test procedures, including the visual inspection of hoses, belts, and fluids, the power steering pump check, and the dry park check, you should be able to pinpoint which steering components need to be replaced. Steering component replacement can be a profitable automotive service business. Once you have determined that replacement of the rack and pinion gear is necessary, refer to the TRW Rack and Pinion Service Manual or a General Service Manual and the TRW instruction sheets. Not all rack and pinion gears are installed the same way. For demonstration purposes, we will be showing the removal and replacement sequence on a GM A-body car that has been diagnosed as having morning sickness. First, remove the negative battery cable and the coil wire and turn the ignition key to the on position. This will free the locking mechanism and allow movement of the steering system. With the lift contacts under the unibody and away from the engine cradle, raise the car and remove the wheels. Disconnect the outer tie rod ends from the steering arm using a tie rod end separator to prevent damage. The tie rod ends, if not worn, can now be reused with the new rack and pinion unit. Push the intermediate shaft boot up, being careful not to damage it. Remove the coupling bolt and spread the coupler to aid separation when lowering the rack. On some vehicles, as is the case here, you must disconnect the exhaust heat shield and exhaust pipe or the AIR system to the catalytic converter. While supporting the engine cradle, remove the rear cradle mounting bolts. Lower the engine cradle 4 to 5 inches. Disconnect the power steering lines from the valve housing. If the valve housing is difficult to reach, the lines can be disconnected at the pump. Some cars can be disconnected at the high-pressure sensor switch, located midway between the pump and the gear, to make removal easier. Remove the mounting bolts to free the rack and pinion unit. Remove the steering gear through the left wheel well. Secure the rack and pinion in a suitable vise, being careful not to crimp the hydraulic lines or damage the housing. At this point, the hydraulic system should be flushed. Temporarily reinstall the engine cradle bolts and lower the hoist. Place a drain pan under the car, then reconnect the negative battery cable and top off the pump reservoir. Now crank the engine over, making sure you don't allow the pump to run dry. You will likely need 2 to 3 quarts of new fluid. The flushing procedure is complete when clean fluid starts to flow into the drain pan. Failure to flush the pump and lines will allow contaminated fluid into the new rack and pinion system. Earlier deterioration of rack seals will result in a leaking gear and a costly comeback. Remove the outer tie rod ends and install them on the new gear if they are still serviceable. Although the external appearances of gears may be different from other designs used by the car manufacturers, the TRW remanufactured gear is designed to fit the application listed. These external differences are a result of unique and state-of-the-art designs used by TRW, designs which we back with a lifetime warranty. Retain the metal sleeve in the mounting bushing and install it on the new rack. Keep the new carton for shipping the core back to your supplier for credit to your core deposit. Disconnect the negative battery cable. Raise the vehicle. Support the cradle and remove the bolts to lower the engine again. Now you are ready to install the new gear. Reverse the steps for installation of the replacement gear, being careful not to damage the bellows or the hydraulic lines during installation. Make sure the gear is fully seated into both mounts. Then install both bolts. Always torque the driver's side mounting bolt first to position the gear. Be sure to reinstall the protective boot over the input shaft. Now attach both hydraulic lines to the new gear, being particularly careful not to over-torque or cross-thread the hydraulic fittings. Failure to follow recommended torque specifications will likely lead to one of the most common installation-related problems: power steering fluid leakage. Note the warning flag on each gear. Refer to your shop manuals or the TRW rack and pinion manual for proper torque specifications. Cross-threading the fittings into the aluminum housing will permanently damage the internal housing threads and will cause the rack to leak immediately when pressure is applied. Over-torquing the hydraulic fittings can result in either stripped threads or a cracked pinion housing. In either case, the rack and pinion assembly has been damaged beyond repair, and a leakage problem will definitely result. On some gears, the hydraulic lines are meant to swivel even after proper torque has been reached, allowing the installer more flexibility in hooking the lines up to the pump. Lower the car, reconnect the coil and the negative battery cable, and top off the pump reservoir. To purge the system of air, lift the front wheels off the floor. Start the engine and allow it to idle while gently cycling the steering wheel. While bleeding, ensure that proper reservoir level is maintained. A smooth, quiet travel will indicate that the system is properly bled. For some steering systems, particularly on Ford vehicles, it may be difficult to evacuate trapped air. An intermittent whining noise, a continuous growl, stiff steering, or shuddering while turning are symptoms of air entrapment. Usually, this trapped air will work its way out if left overnight, or it may be necessary to use a power steering pump evacuating assembly to purge the trapped air. Check your shop manual for specifications and procedures to fabricate and use a devac tool. The next step is to perform a wheel alignment. After aligning the vehicle, be sure to clamp the small end of the bellows onto the inner socket assembly. Small clamps are supplied with the remanufactured rack, but cannot be tightened until you have completed the alignment. Otherwise, the bellows will likely twist and become damaged. Although some original equipment manufacturers attach the small end by fitting the bellows into a groove in the inner socket, TRW remanufactured units always require a clamp to ensure a good seal. Road test the vehicle. If a shudder is experienced, raise the passenger side of the vehicle approximately 6 inches and briefly cycle the wheel. This procedure will purge any remaining air. To ensure a professional job and to prevent costly comebacks, remember the following service tips. Read the instruction sheet supplied with the remanufactured rack. Not all racks are installed the same way. Flush the system of any contaminated fluid to prevent any abrasive particles from damaging the seals in the new rack. Be careful not to over-torque or cross-thread the hydraulic fittings into the rack housing. Some racks are designed to have the lines swivel after they have been tightened to specification. Purge the system of any trapped air. Make sure that both ends of the bellows have been secured after alignment to prevent road contaminants from entering and damaging the new rack. A short rack is a rack and pinion unit less the inner socket assemblies and bellows kits. Some OE dealers offer only these units, and while at first the cost may seem attractive compared to long racks, it's often not long before the difference is eaten up when components like tie rod ends, bellows, and associated labor costs are added. TRW offers short racks to allow the customer a choice. Removal and installation of short racks is identical to that of the long racks. However, disassembly and reassembly of bellows and inner sockets will be required when servicing short racks. Obviously, inner sockets must be checked to determine their suitability for reuse. Otherwise, replace with new inner sockets. Discard the old bellows. New bellows must always be used when servicing short racks. To remove the old inner socket assemblies, use a proper holding fixture or place the unit over the end of a bench to prevent housing distortion. Use an open-end wrench on the exposed rack teeth to prevent rotation and damage to the gear teeth. Remove the set screws, jam nuts, steel pins, or any other locking device that holds inner socket assemblies to the rack gear. Now remove the old inner socket assembly. While removal and installation stays the same, different types of socket assembly designs require special mention. On end steer gears, where the tie rod ends are attached to either end of the rack, 4 types of assemblies are common: the drill and pin, the set screw, the roll pin, or the crimp mount socket assembly. To remove a drill and pin style socket assembly, cover the end of the rack housing with a clean shop towel to prevent metal chips from entering the seal area. Drill out the roll pin with a 5/32 inch bit to a depth of 3/8 of an inch. A piece of tape on the bit serves as a depth gauge. Clean all metal chips away from the rack threads. Loosen the lock nut if there is one and discard it. Remove the socket assembly. Follow instructions for installation of the new assembly. Torque it to proper specifications. Proper torque of all types of assemblies is critical to allow free movement of the stud and prevent unthreading from the gear. Set screw and roll pin inner sockets are encapsulated assemblies. The set screw or roll pin rides in a channel to lock the socket assembly to the rack gear. To remove the assembly, first remove the set screw or roll pin. On this roll pin design, you will need diagonal cutters or an easy out to remove the pin. Loosen the lock nut if there is one. Then remove the socket assembly. Next, install the new assembly. On a set screw assembly, tighten the set screw until it is properly seated. On a roll pin design, install the roll pin with a hammer, tapping until it sits flush. Torque each assembly to specifications. On the crimp mount design, the inner socket assembly is staked onto the rack at the flat spot on the back. Slide the shock damper from the inner socket assembly. Loosen the lock nut if it's so equipped. Then remove the old socket assembly. For reassembly, slide the shock damper over the rack teeth and install the new socket assembly, torquing it to the proper specification. Crimp the end of the assembly and slide the shock damper in place. After servicing the inner sockets, install new bellows and be sure to secure the large end of each bellows with proper clamps. On center steer gears, the type of inner assembly is different than those found on end steer gears. The center steer design links the steering arms into the center of the rack instead of off the ends. This configuration takes up less space in the vehicle. To service the inner socket assembly of this type of gear, first release the lock plate. Next, remove the inner socket assembly bolt and take out the assembly. Replace the old assembly with a new one. And finally, bend the lock plate tabs to secure the bolts. You have now completed the necessary steps to convert a short rack into a long rack. Before installing the rack on the vehicle, remember to flush the system during installation. Be careful not to cross-thread or over-torque the hydraulic lines. Remember to purge the system of any trapped air. After you have aligned the vehicle, ensure that you secure both ends of the bellows. TRW's extensive involvement in the manufacturing of rack and pinion gears, along with the most thorough testing procedures in the industry, has allowed TRW to stand behind the broadest line of remanufactured gears with a lifetime warranty, the best in the industry. Quality workmanship from the installer and quality products from TRW lead to satisfied customers. At TRW, quality is just the beginning.